A box containing a new bookshelf with a gravitational force of 300 newtons moves with a constant velocity across the floor when it is pushed with a force of 450 newtons exerted downward at an angle of 36 and 6/10 degrees below the horizontal. Find the coefficient of kinetic friction between the box and the floor. Okay, just like our other problems, first I'm going to do is draw a picture. So here's the box. And it is along the floor. It's going to slide along the floor when it's being pushed downward. So maybe somebody's standing over here and they're leaning and they're pushing it downward, okay? And across, but at an angle downward, okay? Now after I draw that picture, I'm going to go ahead and draw the free body diagram. It's going to give me more information. So this box, I know there's an applied force downward at an angle of 36.6 degrees below the horizontal. So I'm saying the box is getting pushed towards the right. So I'm going to go ahead and draw a little dotted line to represent the horizontal. And then an angle of 36.6 degrees below that. So something similar to that. And I'll label the angle as 36.6 degrees. Now, I need to go ahead and label the rest of the forces in my free body diagram. Well, it's not just an applied force. When they apply the force, it says it's moving along at a constant velocity. That means it's moving along a surface. Therefore, there's going to be kinetic friction. This is a box, and it does have a weight, so it has a gravitational force acting on it in the downward direction. And it is on a horizontal surface, so the normal force is going to be acting directly upward. So now we've got our free body diagram. We look at this free body diagram, and it's a little different than the other ones we've had. Before, we always had our forces either horizontal or vertical, and now I've got this one at an angle. When this happens, what we are going to do is we are going to break that force down into components. Okay, we're going to break this applied force down into components. We're going to call those components the parallel component, the one that is parallel to the direction of motion, and the perpendicular component, the one that's perpendicular to the direction of motion. So I'm going to go ahead and draw this in. So this green dotted line is going to represent the force that is parallel to the direction of motion, and then this red dotted line will represent the component of the force that is perpendicular to the direction of motion. And now I'm going to go ahead and find those values using a little bit of trigonometry that we've done before. So this is the adjacent side. I know the applied force is 450 newtons. So this side is 450 newtons. That's my hypotenuse. So I've got my adjacent, my hypotenuse. So I'm going to use the trig function of cosine. So say the cosine of 36 and 6/10 degrees is equal to the parallel side divided by 450. To solve, multiply both sides by 450, and you will get 361 newtons and 27 hundredths. Okay, then I'm going to go ahead and solve for the perpendicular side. That's the opposite of the angle. So I've got opposite. I'm still going to use this 450, which was the hypotenuse. So I'm going to use a trig function of a sine. So the sine of 36 and 6/10 degrees is equal to the perpendicular component divided by 450. Multiply both sides by 450, and we will find the perpendicular component is equal to 268 and 3/10 newtons. So now we've got our parallel component, our perpendicular component. So now we can look at this as all the horizontal forces and all the vertical forces. Okay, we can kind of ignore this part. Okay, so let's go ahead and see. What exactly do we know? I'm going to write down my givens. Well, we were given the applied force was 450 newtons. From that, we found the perpendicular component was 268 and 3/10 newtons. And we also found the parallel component was 361 and 27 hundredths newtons. So I'm not really using this one anymore. Okay, I've broken it into its components. But I also up here was told the gravitational force. So I'm going to write that one down. So the gravitational force is equal to 300 newtons. So now I've got all my givens. What am I trying to find? Find the coefficients of kinetic friction. So I'm trying to find mu sub k, the coefficient of kinetic friction. Well, the only equation that is in the force of kinetic friction is equal to the coefficient of kinetic friction multiplied by the normal force. I look at this equation. I don't have the force of kinetic friction written down in my givens. I don't have the normal force written down in my givens. So I need to find them. There's got to be something else in this problem that's going to give me a hint as to how I'm going to find them. And that is this part right here. It says the box is moving with a constant velocity. Anytime the object is moving with a constant velocity, we know it is in equilibrium. And when an object is in equilibrium, we know that the net force in the x direction is equal to 0, and the net force in the y direction is equal to 0. We know both of those things. So we're going to use them. So I'm going to look for the x direction forces. I look over here at my diagram and I see I've got the force of kinetic friction acting to the left. So I'm going to make that negative. The force of kinetic friction acting to the left. And sum means we're going to add them up. So I'm going to add that to, I've got this F parallel, and that is going to the right, so that's positive. And those two are going to add up to 0. Now I look in here and I say, hey, I know F parallel, so I can substitute it in. Solve by adding the kinetic friction to both sides, and we will find we get 361 and 27 hundredths newtons for the force of kinetic friction. Now we need to go ahead and look at our y direction. And this is where it gets a little bit different from what we'd been doing before. Okay, in the y direction, I'm actually going to have 3 forces there. I have the normal force going up, so I'll make that positive, plus, then I have the gravitational force going down, so I'll make that negative. We usually say the downward direction is negative. But that's not all. I also have the perpendicular component, and that is directed downward. So I'm going to make that negative as well. So I now have 3 forces in the y direction. So now I'm going to substitute it in and see what I get. Well, I don't know the normal force. I do know the gravitational force, so negative 300, plus I also know the perpendicular component, negative 268 and 3/10. And those are all going to add up to 0. So if we go ahead and solve this, I'm going to find the normal force is 568 and 3/10 newtons. Now I do know these things. I know the force of kinetic friction, and I know the normal force, so I can solve for my coefficient of kinetic friction. So go ahead and do that. So 361 and 27 hundredths is equal to the coefficient of kinetic friction multiplied by 568 and 30 hundredths. Divide both sides by the 568 and 30 hundredths, and we'll get our coefficient of kinetic friction is 64 hundredths. And again, there are no units for the coefficient of kinetic friction. It is simply the 64 hundredths.